All right, this is 7th grade, Module 4, Lesson 12 on scale factor as a percent for a scale drawing. All right, so we're going to start here by looking at this figure over here, a little snowman. In the middle, you'll see we have the original. So that's the very first image drawn, or the original that we're going to use. Okay, then we have a smaller version, is figure A, and we have a larger version, which is being shown as figure B. So looking at that, we can look at these opening questions here. Compare the corresponding lengths of figure A to the original octagon in the middle. This is an example of a particular type of scale drawing called an reduction. This is when we reduce an image. So if you look at the original and we're going to figure A, we're reducing the image. Okay? And down here it says compare the corresponding lengths of figure B to the original octagon. In the middle, this is an example of an enlargement. Okay, so an enlargement is when you get something greater than the original. A reduction is when something is smaller, than the original. Let's try that again. All right, move that back up. There we go. All right, trying to make it a little bit bigger down here. There we go. So the scale factor is the quotient of any length in the scale drawing to its corresponding length in the actual drawing. Use what you recall from Module 1 to determine the scale factors between the original figure A and the original figure B. All right, so A, if you look at the lengths, I'll kind of go back up here real quick. Move my colors out of the way for a second. If you look back up here at the image, you see we have a length of 1.5. The original is the length of 3, and the enlargement is a length of 4.5. So we're going to use those side lengths. We also have the side here of 2, 4, and 6. So what we're going to do is take those measurements and turn them into a ratio type. So that way we can kind of compare. So for A, we have 1.5 over 3, which we can reduce down to 1/2. And we have figure B, which was the largest one, of 4.5 to 3, which can be reduced down to 3 over 2. All right, so we're going to use some of these numbers here for our table that's coming up. So let's go ahead and move on down to the table. All right, so on this table, let me close that out. On this table, you see we have the horizontal measurement. Now, horizontal means we're going in this direction. Okay, then we have the vertical measurement. Vertical means we're going in this direction. And then we have a concluding statement. All right, so for figure A, as we found just before, that was a horizontal measurement of 1 to 2, which percent-wise is 50%. All right, then we could also take the measurements for the vertical, which was 2 to 4, and that also comes down to 50% as a percentage. So what can we conclude? We can say the reduction of 50% from the original. So the original was in the middle. It was the middle part of that snowman. And the head of the snowman was reduced or made a reduction of 50%. All right, now let's look at figure B. This was the larger format. And if you remember, we had 4.5 to 3, which comes to 1.5. Now that is a percentage. If you remember, we move our decimal 2 places to the right to find a percentage, comes to 150%. Now this makes sense because the original, the middle version, is always 100. So anything less than 100 is a reduction. Anything greater than 100 is an enlargement. Let's look at the vertical measurements. We had 6 to 4, which also comes to 150%. So we can conclude that an enlargement, oops, forgot my E there, enlargement of 150% from the original. All right, let's look at example 1. I'm going to go ahead and move this up a little bit. All right, so we're going to create a snowman on the accompanying grid. Use the octagon given in the middle of the snowman with the following conditions. All right, so calculate the width, neck, and height in units for that figure to the right. All right, so let's first count that up. All right, so the width. Now the width is all the way from the farthest point to the other farthest point. And you literally want to just count the units between each point. And if you count it up, you get 20. So the width is 20. And then we have the neck. All right, now the neck is from here to here. And if you count up all these units in between, you should get 12. And then we have, oh, excuse me. I actually solved for the height there. I apologize. It's the same number, and that's why I got them mixed up. So the height is 12. All right, the neck goes from here to here, which is also 12. So you have 20, 12, and 12. So now if we create a snowman using the scale factor of 75%, 75 being less than 100 means we're going to reduce it. What would be my new measurements? Okay, so I'm going to say my width is going to be 0.75, taking 75%, turning it into a decimal, times the original, which is 20, which means it went from 20 units now to 15 units. All right, my neck, take 0.75, times that by 12, and now I have 9 units. And the height, take 0.75, times that again by 12, and I get 9. So since we're making a reduction, we're going to put that on top since we're building this snowman here. Okay, now again, this is the original. So instead of going 20, I'm now going to go 15. So if you kind of think how many you can take off there, I would say 1 for 1, 1 for, okay, so that's 1, 2, kind of eyeball it, and then you come up here and you're going to draw this out. So that's 12. I would say 13. I'd go right about there would be my new width. All right. Now, I'm going to try and pick a different color here. Of course, yours is going to look a lot better when you're not doing this on a tablet. The neck here is going to go from 12 to 9. All right. So we're going to go, this is 12. We're going to do 11, 10. So probably like right about here, and then bring this one in 1. All right, and again, just count that and make sure it's 9. I'm just kind of guessing right here while I'm trying to do this really quickly. And then our height. Our height's going to go from 12 to 9 again. So we're going to go, let's say that's 11, 10, I would say right about here. I think it should be like right about there. But again, check it out. Try it out. You want 15 going across. So I'll kind of draw it up. You want 15 across, 9 down with a width also of 9. All right. So take your straight edge, count that out. Be a lot easier to count the squares when you're not staring at a computer screen that looks awfully light. So I'll let you take the time to draw that. And if you need to pause the video, go ahead and pause. And I'll meet you on the next problem. Okay. C. To create the bottom of the snowman, this is going to be the enlargement piece of the scale factor. From the middle snowman, use the scale factor of 125%. So I'm going to start this one off, and then you're going to finish it up. This is going to be one I'm going to grade. So we have the width, we had the neck, and we have the height. Now we're going from 120%, 125%. So 125% as a decimal is 1.25. So we're going to say 1.25 times 20. 1.25 times, oops, my pen just went a little funny there. See if I can fix that. Times 12. And 1.25 times 12. All right, you're going to solve those out, and that'll be one that I grade. Okay, is the head a reduction or an enlargement of the middle? Well, we already know that the head is going to be a reduction of the original. And how do we know? A reduction by 75%. The 75% was less than 100, so that makes it a reduction. I'm going to move this up real quick. All right, and so the bottom is it a reduction or an enlargement? This one was an enlargement. And what kind of gives it away is the percentages. So this is an enlargement. I should probably put the word of there, of 125%. Okay, so I've kind of said it a few times, but what makes this relatable to the original? Okay, so it says, what is the significance of a scale factor as it relates to 100%? What happens when such a scale factor is applied? All right, so what this is asking is the 100% represents the original. Even if the original is the smallest image. A lot of times students think, oh, I have to go with the middle-sized one or the largest one as the original. Sometimes the original is the smallest one up there and they enlarged it twice. That can happen, okay? A drawing less than 100% is a reduction. So even if it's 99%, that is a reduction. And if it is more than 100%, it is an enlargement. And that can be 101%. 100% always goes to the original. All right, now G says use the dimensions you calculated in parts B and C and complete the snowman. All right, well, you're going to go back to example 1 and you're going to finish drawing up the head and the bottom of that snowman. All right, and now we're on to example 2. Okay, example 2. Here we go. Create a scale drawing of the arrow below using the scale factor of 150%. So first we need to count our units. So here we have 2 units. Going across along this way, let's see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 12. And then we're going 1 up. And then we have a diagonal slant here where we're going to go 2, 4. So this is 4. All right, so that means that's 12, this is 1, and that's 4 as well. Okay, so here we go. We have 2 times 1.5. And I'm just going to show you this, how you guys can use your calculators. Let me pull up my calculator here just to kind of show you. All right, I also have 12 times 1.5, and then we have that slant. But you know what? Actually, let's count from right here. 1, 2, 3, 4, 5. Let's use 5 here for the arrow as well. So I'll say 5, and then we'll just slant it in. Times 1.5. That'll give us a more accurate arrow. Okay, so we go 2 times 1.5, and we get 3. So instead of 2 boxes, I'm now going to move to 3 boxes. And we have 12 times 1.5. I'm going to get 18. And I have 5 times 1.5, and I get 7.5. Now 7.5 is going to be kind of having to guess a little bit, so we'll try our best here. All right, so if you have a straight edge, you need to make sure you use some sort of ruler or straight edge of some sort, okay? You can pick anywhere on this graph paper because the image isn't that large. All right, but I do see that I am 1, 2, 3 dots off the graph paper, so I'm going to kind of keep that going. 1, 2, 3. So I'm going to start here. Now, instead of 2, I'm going to go 3 units. So there's my 3 now. All right, and then I'm going to count 18. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And hopefully yours is a lot better looking because it should be nice and straight. Okay, so this is now 18 and 18. Now again, I went from 5 to 7.5, which means it's going to fall between that dot. And that was right here. Oh, I didn't do the 1. Well, let's figure out what that is. So I'll show you on the calculator. Oops, and I shifted this over. I'll fix that. 1 times 1.5 is 1.5. I like to show that one because so many times kids think I'm kidding them when I say that. So I'm going to go, hopefully yours is a little bit better. So 1.5. Okay, 1.5. That one's not perfect. Not the easiest thing to do on a tablet. Okay, so I'm going to go from 5 to 7.5. 1, 2, 3, 4, 5, 6, 7.5. All right. There you go. So there's your enlarged image of 150%. Example 3. Scale drawings where the horizontal and vertical scale factors are different. All right. So we have this picture of this house, okay? And I'll just go ahead and read here what it says. Sometimes it's helpful to make a scale drawing where the horizontal and vertical scale factors are different, such as when creating diagrams in the field of engineering. Having differing scale factors may distort some drawings, may make it look kind of funny. For example, when you are working with a very large horizontal scale, you sometimes must exaggerate the vertical scale in order to make it readable. This can be accomplished by creating a drawing with two scales. Unlike the scale drawings with just one scale factor, these types of scales drawings may look distorted. So next drawing below is a scale factor drawing with the horizontal scale factor is 50% and the vertical is 25. So the ones that we've been doing, we had a reduction of 50, let's say, or a reduction of 75, and I reduced the whole image by that amount. Now we're only going to reduce the horizontal by 50 and the vertical by 25. So we are going to get some interesting looking images here. Okay, so let's try this out. Okay, so we have the horizontal. Now, if you remember, horizontal goes side to side of the house. Okay. All right, now if you count the horizontal here, let's see what we have. We have 1, 2, 3, 4, 5, 6, 7, 8. So we'll say 8 units. And the horizontal scale factor is 50. So we're going to times that by 0.5, and we get 4. All right, now we have a vertical of the house. Okay, and the vertical of the house, I'm going to assume it's this one here, because this one says vertical scale of 25. So this is going to be the finished product. So we have 1, 2, 3, 4, 5, 6, 7, 8 as well. So 8, and this was the vertical. So vertical is 25%. So we're going to multiply that by 0.25, and we're going to get 2. All right, and then we have the vertical top of the house. All right, and the vertical top of the house, we have as 1, 2, 3, 4. And again, we're going to say 4 times 0.25, which gives us 1. All right, so if we were to create this new drawing, those would be the units that we would use on that one. All right, let's give this another try on exercise 1. All right, so we have a exercise here where it says create a scale drawing from the following using a horizontal scale factor of 183 1/3 and a vertical of 25%. All right, so let's talk about our scale factors first. We have 183 1/3. We're going to put that over 100%. Okay, I'm going to get my calculator here. All right, now in order to get rid of the denominator in that 1/3, we're going to do 183 times 3, okay, which is going to give me 149. Now, why I'm doing that is I want to get rid of this denominator. So you have to multiply everything by that 3, including the denominator down here. So it cancels there. 183 times 3 gives me 549, but you can't leave off that 1, which means we just add it back in. And then 3 times 100 is 300. So now we have to add back in the 1, and I get 550. All right. So I now have 550 to 300, and I can reduce that down to 11/6. So we're going to use 11/6 as our horizontal scale factor. So our horizontal distance, let's talk about that. We have distance going horizontally, 1, 2, 3, 4, 5, 6. So I have a 6. All right. So let's solve that one out then. I'm going to say 6 times that scale factor of 11/6 now. These 6's cancel because they're actually diagonal of each other, leaving me with 11 units going horizontally. So when I redraw this, I'm going to go 11 units. Now let's talk about the vertical. Okay, my vertical scale factor, so that this was horizontal, my vertical scale factor is 25%, so 25 over 100, and I can reduce that down to 1 to 4 is my scale factor. So I'm going to count my vertical, which is going to be 1, 2, 3, 4. So I'm going to say 4 times 1/4, and the 4's cancel, leaving me with 1 unit. So you're going to redraw this, and I want you to go 11 units this way, but just 1 unit up. So it's going to be kind of taking this image and flattening it, but sticking the sides out. All right, give yourself a chance to draw that. If you need to pause the video, you can. And exercise 2 is on you guys. So I'm going to let you figure out exercise 2, and that is the end of this video tutorial.